What's good, yo? Welcome back. Today's gonna be a very short video because I'm just gonna review what I've been working on briefly today. Um, I didn't really get the chance to sit down and record, so I would just boot up the laptop for a few minutes at a time when I was free and just think about this project. So what I basically did today and last night was I so far, what we have done is we calculated the longitudinal acceleration with the bicycle model, and we have yet to calculate the longitudinal deceleration because that has a different equation. Um, if we go to my site where I took notes on openlapsim, this is the equation for calculating the longitudinal acceleration of the car. Obviously, this is for point mass, but we extended this to the um, bicycle model right here, as you can see. So we have to do the same for the deceleration. As you can see, it's a slightly different formulation. So that's on the to-do list for tomorrow. Calculating the longitudinal deceleration. And then we also have to calculate the lateral acceleration, which should not be as problematic because I don't think we have to use optimization routine. But I was looking at the paper that um as part of my like research for this project. And this is the formula they use for the lateral acceleration. And I don't know if I already calculated the normal force and the normal force at the front and the rear, but that's also on the to do. But so far, so what I've done today and yesterday is um, I plotted the speed trace of the car and just replaced the longitudinal acceleration with the bicycle model one. I kept everything else the same, and I just wanted to sort of compare the solutions. So this is the solution from the point mass simulation. So we can see a lap time of 121 and then a top speed of 300 km/h. This is what the graph looks like. So this is the longitudinal acceleration here, and then we have the much more stronger deceleration curve going on the other side. And um this is like the speed trace. I'm sorry for the two curves here. The one that's a bit forward here, that's AXACC. Don't worry about that. Just focus on the blue one that's lagging a little behind. That's a velocity speed trace. And then these are some more other graphs. These are all graphs that are created by the original author of openlapsim. So this is all his work. So this is all pure point mass. So I just replaced the longitudinal acceleration calculation with the bicycle model one with this newly revised acceleration envelope calculator BM file, which is, as you can see here, the longitudinal acceleration is calculated here. And then so this is what the plot looks like. It's smoother, but it follows the same shape, but it's slower, but it's different, but it's like I think we're on the right track, and these are the um same graphs. So if we look at the graphs, actually, there's quite some analyzing we have to do. So let's look at the graphs. So this is the speed trace for the point mass car, and this is the speed trace for the bicycle model car. So point mass, bicycle model. So the bicycle model car is definitely slower and it has lower resolution, it seems like. Like here, the point mass one, there's more braking going on here. I don't know what's going like. This is why I generated the image of the track. Oh yeah, anyway, sorry. Um so it's slightly different. It's quite different, slower, but the general behavior is roughly the same. So we're gonna have to look into this. And I think, yeah, so this is the point mass. This is the longitudinal bicycle. So what's happening here is because the point mass calculations are all discrete. Um, the simulator is like it calculates it in discrete steps as opposed to the optimization routine, which calculates the um like the longitudinal acceleration calculation, the root finding. It relies on a continuous function, and I think because of that, it because also we had to smooth out the maximum and minimum functions. It ended up smoothing these curves out. I might be totally wrong, but that's my estimate, and that's my hypothesis. Like it's a result of the smoothing, but we had to because that's how we find like because of just how the complicated the function was. So that's yeah, so it's good. It's really great results actually so far. We just have to do the longitudinal deceleration, and then we also have to calculate the lateral acceleration, and then I want to do a final chart, speed trace, compare those, and then we'll go from there. If I ended up making like a all right passable bicycle model lap time program, then it would be sick to have a graphical user interface to follow up that project. So I'm looking forward to it. So yeah, I'll see you guys tomorrow.